Welcome to Lesson 9. I'm going to call it Part A and Part B, because in Part A I'm going to talk to you about servicing your lathe in terms of routine maintenance. Part B, we'll step over to another part of the studio and we'll bring out the chucks. And I'll talk to you about how to take them apart and keep them in best operating shape. So first thing I want to do is to say I'm not at the same lathe I was for all the other lessons. I try to pick a lathe that's more typical of what most turners would be using. However, what I say about this smaller Delta lathe will be the same as would apply to any other machine. All lathes are consisting of the same components. Some are just bigger or smaller than others. So the same lessons will apply elsewhere. So I want to show you the things that I've laid out to make this job easier for me. So I'm going to step over to my cart, which I've gone and laid out all the tools and supplies I think I might need for servicing both the lathe and the chuck. So let me show you what's on my cart. Over at the cart where I rolled out my tools, I want to kind of show you the things that I set aside to use. First of all, I've got a pair of adjustable wrenches. I don't know when I approach a lathe whether the screws and nuts and bolts are metric or imperial. Some of the items made in Taiwan were made with imperial threads at a period of time, and then later made with metric threads again. So if you don't know, at least use adjustable wrenches. I went to the hardware store, picked up a pair of Allen wrench keys. This one's imperial, metric again. You need both of them just to be safe, and they're not expensive. Go to your woodworking dealer and get one of these taper cleaners. This one is a Morris Taper 2, which will fit the head and tail stock of all the lathes we have here in the classroom. But keeping your taper clean is important. For maintenance, you need to have a file. These are called mill bastard files, and they're available for $6 or $7 at any hardware store. And I'll show you, you absolutely need to be able to use this on your tool rests. I went to Harbor Freight and picked up a set of 3 brushes for a couple bucks. One's fiber, one's steel, and one is brass. And these brushes are a good way to keep dust out of threads like our headstock thread. I've also got a can of duster, which you might use on your keyboards or your computer, but also there's times when you might want to just blow some dust out, especially when we get into cleaning the chuck. I don't use WD-40 on any of the surfaces that slide, because dust will accumulate and stick to that, and that's not any good. So I always use an industrial silicone spray. It dries completely, provides the slipperiness that we want, but doesn't attract the dust. You'll need some sandpaper. Doesn't matter whether it's a strip or not. Generally 180 to 220 is a good size to use. We're going to clean surfaces with these. To protect my surfaces eventually, I'm going to use a little paste wax on the top edge of the tool rest. Many people recommend just using some wax, just rubbing along the edge. Allows your tools to slide along more easily. Paper towels, of course. And this is going to get messy. Having some gloves, keep your hands and your nails clean is not a bad idea either. Let's go back to the lathe, and I want to talk to you first about some of the safety things that you need to do in just operating your machine to prevent damage. And then we'll talk about repair and cleanup items. So back to the lathe. We're back at the lathe, and I want to point out a few things that we find with most of our beginning students that cause problems with their machine or with ours here at school. First of all, this lathe has a spindle lock, and many times people turn that on to unscrew a chuck or a device and then leave it there. So if I hit the power switch right now, that belt isn't going to slide. We're going to maybe burn the motor up, certainly kick the relay out. So always be sure when you finish that you disengage any spindle lock so that you're turning free. Many lathes come with a tool rest that has a steel bar across the top. Many other lathes come with one that's all cast iron like this one. These cast iron ones are softer. And when you get a catch or bang on the tool rest, we get dinks in this. And those dinks become problems when we're doing very fine work like maybe turning a pen. The steel bar ones are much less prone to that. So one of the upgrades to your lathe might be to replace that with something like this that has that steel on the top. Actually, this one is almost twice as long and gives me much more working room. This is what came with the lathe originally. So let's take the tool rest off and look at one of the first maintenance issues we have. The banjo needs to move freely and lock tightly with very little pressure. Same thing with the tailstock. It should slide smoothly and lock that way. Sometimes when you push the handle down, it doesn't lock, or the handle goes all the way around. The issue is here. This handle operates an eccentric cam, which pulls this washer up against the bottom edge of the waist, locking it. If it doesn't lock tight, it's because these two nuts have loosened. And so we'll tighten the top one slightly, maybe a quarter of a turn, and then tighten the second nut to lock the first one from moving. So that needs to be done to prevent that. On the banjo, the bottom is exactly the same. So we have these eccentric cams, and these nuts will loosen on some lathes. On this particular brand lathe, there's two locking nuts. On other brand lathes, there's one nut that's called a nylock, which has a plastic or nylon insert, which prevents it from moving easily. If the lathe handles are over tightened, down like that, one of the things happens is that nylon insert can be stripped out, and the nut then may need to be replaced. They certainly do loosen a little bit and need to be retightened. That's where we need our crescent wrench. Small one in this size is a good size to work around these lathes. So keep that nut tight so I can lock this. So I can lock this, and it's firm. Sorry about that noise. One of the things I want to check on this machine, because I haven't done it for a while, I grabbed off the cart two items: a spur drive, which I'm going to insert into the headstock after I've cleaned the taper. Did you see the stuff come flying out of there? Maybe you did, maybe you didn't, but there's a lot of debris accumulated inside this taper. And what happens with that, the things that get pushed in here, like a spur drive, and in this size, a live center, won't seat properly or straight. So I put a spur here, and I put a live center here, and I'm going to bring the tailstock up close, lock it off, and advance it till the points almost touch, and lock the quill. I'm going to look down, and my goal is to see if those 2 points are aligned in this plane. I'm going to look at across this way, and I'm going to see if they're aligned in this plane. If they're not, then we have a misalignment that will probably not show up in bowl turning, but it will show up in smaller work like finials and pens, where roundness is really important when we fit up against a fitting. If it's not aligned, those fittings will look like the wood has been turned oval instead. How do I adjust that? Well, there's not a lot of adjustments that are made into the thing, but these 4 screws, 2 in the front, 2 in the back, on the headstock, on all these smaller lathes, can be loosened. Shims can be placed under the right corner to bring it into perfect alignment and then secured down. On the larger lathes, other techniques may be available, but these 2, spur drive and live center, must be aligned. This one looks pretty doggone good. Now if I loosen this, there's a certain amount of play. Has to be, or this won't slide. So I need to know that if I push it back this way, I'm slightly out. If I pull it forward when I lock it down, I'm right on. So I know when turning a pen or other small items, I'm going to bring my tailstock up where I want it, pull it the direction I know I need to go, and lock it down. So those stay in perfect alignment. I said something about the problem with this quill. getting really hard to turn. And that happens a lot when this screw has been mistightened in the wrong place. And let me show you how to fix that. Take this out, that for safety. I'm going to loosen this screw. And then I'm going to unwind this until the quill literally comes out. And I can examine this. And I can look at all these surfaces and see if they're smooth or have been damaged by having this tightened in the wrong place rather than in this groove. This one looks pretty good. Actually, there's no problems with this particular one. If there was, I would take my file and find those mushroomed out spots and file them back down to round. And then when I put this back together again, I guarantee you it's going to work just fine. So I put it back in place, lined up where it's supposed to be. And now I'm going to put this back into the slot. Now tight, but a quarter loose. And I'm back in operation. Lubrication's important here too. This is where I'm going to use my, I happen to have a particular brand I just picked up at the store, but this is a silicone spray, and it's used a lot in machine tools. What I'm going to do, run the quill way out, a little spray, and if that messes too much, just take a piece of paper towel and wipe off the excess. That's running like smooth as silk. The other surface is this. And on this particular lathe I see there's a couple of spots where probably something from some former project has marred the surface. So I'm going to clean it a little bit. Maybe just a little sandpaper. One particular spot on this one I can see. I'll sand those marks away. Wipe off the residue, a little black from there. Nice little bit of silicone spray. Oh, that's wonderful when it works like that. Where else mates with that? It's the bottom of this surface. So I'm going to clean the bottom of the banjo. A little bit of silicone spray on it. Mating metal surfaces. Look at that. Just like when it was brand new. Guess what else? Same thing here. I have this surface here that needs to be kept smooth. And I can see this one has all sorts of sawdust on it from past projects. A little bit of that silicone on here. As good as brand new. What else could we do on the lathe? Probably not too much more in terms of routine maintenance. There is a belt in here. The belt is made out of some sort of material that will abrade over a period of time and get stiff and may need to be replaced. So you should look at the owner's manual for your lathe on how to change the belt. It gets the time when you may actually need to do that. Since all of them have motors transferring power to a spindle on a different axis, there's always a belt interconnecting them. So those belts, study, find out where the replacement belts come from. There are belt treatment sprays that you can use. You're not going to put oil or WD-40 or silicone spray on those. That'll cause it to slip too much. So the other thing we need to do is make sure that tool rest is exactly the way we want it. Here's that old cast iron one I talked about. And if I can look at the top edge of this, I can see it's badly abraded. And those probably, on a very regular basis, need to be cleaned. And it's done with a file. It's a soft metal. And I'm going to file this until I can no longer see any scratches or dents in it. And I'm not going to bother you with watching me do this because it's pretty deep in a few places and it's going to need to be filed down some more. When that is done, little wax on the tool rest is going to allow that tool to slide smoothly along here. I don't want to wax this. Wax will build up a surface and impede this free movement, which I don't want to do. So, lathe, routine, maintenance. The other things you need to do on a regular basis, always keep checking your power cords to be sure that it hasn't been pinched, where it goes into the wall, that it's plugged carefully, that we don't have any electrical shorts that we're worried about. So keep checking that. In my book on the basics of wood turning, there's a chapter on lathe maintenance, and I have a chart in there about how frequently you might want to check each of these things. I would check my tool rest once a week. I'm going to clean the ways and the bottom of the quill and banjo, depending on what work I've been doing. If I've been working with dry wood, it's not too much of a problem. With green wood, the sap will cause these surfaces to bind much more rapidly. So it may be once a week or once a month, depending on what I've been working on. Part A. Let's move to another part of the shop. I'm going to lay out a couple of chucks, and we want to talk about how to keep our four-jaw scroll chucks working as best possible. So I'm going to step over to a table where we can get closer and take one apart, put it back together again. I've stepped over to a table and laid out a couple of chucks to take a look at. There are two basic styles of chucks. There are those that are manufactured with an open back like this one, which will tend to accumulate more debris more rapidly. And there's brands that have a closed back. Same problems will happen, but because it's closed in the back, debris getting down into the gears happens less frequently. So I'm going to take one of these apart. The insides of all these scroll chucks are pretty much the same. First thing I'm concerned with is the quality of the jaws themselves. So I'm just going to unscrew one of these, have you look at it. It's held on with 2 screws. Some jaws are held on with only 1 screw. And here's the first problem we're going to run into. Put my glasses on so I can see. Inside of this jaw, where it grabs the wood, is just packed with sawdust and debris. Look at that. Well, what that means is the fact that these are going to grab the wood less easily and less substantially than when it's clean. So the first thing we've got to do is to clean the debris out of those grooves. Now, some of this can be done on the lathe, on the chuck without taking the jaws off, but it's easier for me to show you this way. If these are not kept clean, you're not going to get good grip on your product. So that's the first thing. I'm using a brass brush, perfectly good. Now here's the back side of that same jaw. These slots rest on alignment locations inside the chuck, and as you can see, the back of this also is full of sawdust. And by removing the jaw, I can clean that. I can come up here and clean the mating surface here. So when I remount this, it'll go back on cleanly. So I'm going to take all these jaws off, do the same thing to all 4 of them, and then I'm going to show you how to take this thing down one more level. So I'm going to remove the rest of these jaws. Two screws. It's a great place for fast forward. Now, every one of these has to be cleaned in the front, in the back, one of the other things that helps sometimes, I have a dental pick, and you can pick these up at some of the discount stores, thing like Harbor Freight. And when the debris gets wedged in here and it doesn't come out easily, one of these dental picks will get down in here and clean that very nicely. Try brushing it first. This one wasn't cleaning up very well. There's debris down in here. May have been a little bit of finish. So each jaw, front, back, front, and that one I already did. Okay. Also, on this particular chuck, one of these jaws has a pin. The purpose of the pin is to ride in either this short slot or this longer slot. This prevents the chuck from opening any farther than this position here. And it allows the chuck jaw to open to its maximum on this side without these coming out. It's a limiting switch. So it has to go, this pin has to go either in this location or this location when you put it back together. So now the body of the chuck. Again, I'm going to clean these mating surfaces. And if they're going to ride in these slots, they are also other places where debris can accumulate. It's possible to take them apart even farther. Take these jaws all the way out, because nothing is preventing that from happening now. So I'm going to take the chuck key and I'm going to open this up until these 4 jaws literally fall out. This is the part that a lot of people are concerned about. Changing the jaws is easy enough. Now, getting it back in has to go in a specific order. But before I do that, these jaws have grooves in the back that rides in this spiral gear here. And each one of these is different than its neighbor. All 4 are unique. So they need to go in a specific order. But also, I want to clean them. And these slots, right into these slots. And that will also cause it to bind. So this is a little bit of brushing. So all I got to do is brush these things out. Both sides. These gears. This probably needs to be done maybe once or twice a year, depending on how much you use wood that chooses to get down inside of here. So I've cleaned all 4, and now it's a matter of reassembling it. But before I do that, a little bit of my silicone spray down in here on the back of those. I'm going to operate this gear a little bit here just to run it free. The last thing I'm going to do is the mating surfaces of these slots I want to clean too. And now it's a matter of reassembling. When I look at this, there's a number 1 here stamped on it. Many chucks will be marked on the end, but it'll be marked where number 1 jaw goes. Each of these, this says 4, 3, 2, and 1. 1, 2, 3, 4. 1, 2, 3, 4. So I'll put them in the right sequence, starting in the right location. So number 1 goes into here. And I'm going to move this spiral gear around so that when I put this in, getting
engages. And before that gear comes around here, I'll go put in number 2. And it's going to engage. I've checked. And I see the gear coming around here to position number 3. Yes. And I'm pushing on it as I tighten this. Around to position number 4. Here comes the gear. Number 4 goes in place. And I put it back together again, and now it's a matter of just remounting the jaws. This is working really, really smooth now. Every chuck is exactly alike, but if these are not in the right order, the jaws will not center properly. They'll be off center. Number 1 goes in one location, number 2 goes next, number 3, number 4. Your jaws are numbered. They need to be reinstalled in the same sequence. And now it's simply a matter of reinstalling these jaws or whatever jaws you happen to have. Remember, the one with the pin goes in one of these slotted locations. So that would go here, and the other 3, it doesn't really matter. And all I have to do now is put those screws back in place. And that chuck is good to go for another several months. If it starts to bind, the key turns hard, take the jaws off, maybe a little air, blow it out. And if it's still binding, then you probably will have to do what I've just done, taking this apart, using the proper key to put it back together again. So we finished our series. We started off with the tools for spindle work. We took you through all those basic tools. We took you through the tools for bowls, and now we've done a little bit about maintenance of the chucks and of the lathes themselves. So we've kind of concluded our first portion of these videos. So what I want you to do is keep coming back, see where we go next. Thanks for watching.